Hello everyone, welcome to the NN Classroom. Today I'd like to share with you a past paper question from 2019, time zone 1 in May. So question number 4, multiple choice, asking for electron configuration. So simply concept from topic 2, the atomic structure. Let's see, they're asking what is the ground state? That means the most stable form when we assign the electron from low energy level to high energy level, so on and so forth, right? The ground state of electron configuration of an atom of chromium, Cr. So given that the atomic number is going to be 24. For this case, how can we do it faster? The first thing that you should recognize, or students should have recognized, is that chromium is no doubt a transition metal. And remember that what we have mentioned in class, for transition metal in the ground state without carrying any charges, there must be either a s electron that either be s1 or s2. So in this case, the first thing that we can eliminate, which is A, because for transition element, it must be occupying the outermost shell on the s subshell, either with s1 or s2. So that's why A is impossible, unless it is talking about a transition metal ion. So the another technique that is also mentioned from previous example, that all transition metal ions having a feature that with no s electrons in the outermost shell. So that's why if they're asking just the atomic state, not the ion state, so that means there must be at least 1 or 2 s electrons, right? And also the second feature about transition metal is that it is going to be filling in the final subshell in the D subshell, the previous D subshell. So in this case, when 4s is the outermost shell, that means they must be having a partially filled D subshell. So that's why for this perspective, D cannot be the choice because we never see any electrons in the 3D. That is impossible, right? And so finally speaking, the only choice can only be B or C, right? And this is the final testing point that students should have recognized according to topic 2. Chromium and also one more member, that is copper, is having a specificity. The specificity is that in the atomic state, one of the 4s electron is now getting back to the 3D in order to fulfill the half fill and fulfill D subshell in gaining the extra stability. So mind you, for the case of chromium and copper is having two special cases, in which for the chromium case, supposedly it should be having the configuration of argon and then 4s2 3d4 according to the logic from the previous members. But then one of the 4s electron will get back to the 3d in order to achieve an extra stability. So that's why it should be getting into argon 4s1 but 3d5. Same case for copper, because copper is having the electron configuration to be argon 4s2 and 3d9 supposedly. But then the same case, one of the 4s will then be getting back to the 3d in order to gain a fully occupied 3d subshell as disorganized and extra stability. So because such a specificity goes to two specific elements, one chromium, one copper, across the transition metal area. So that's why the ground state for chromium should be having a half fill 3d subshell, but just one 4s electron. But still, there must be 4s electrons. As just mentioned, this is going to be the feature of a transition metal in an atomic state. That means not ion, right? Because as we have mentioned, if it's going to be an ion situation, the transition metal do not bear any 4s electrons anymore. So that's why for this case, the answer will going to be argon 4s1 and 3d5. So that's why the answer is going to be C.